Where we are organizing this data? We are organizing this data basically on the computer main memory. Non-primitive data structure is divided into linear and non-linear data structure. Non-primitive data structure, a structure that cannot be, here you can see, that cannot be manipulated directly by the machine instruction. The process of removing the element from the data structure is called as removing or deleting operation. Hello everyone, welcome to very first session on the subject data structure. We are dealing this subject for the second semester B.Ca student. Myself, Induje, Faculty of Computer Science Department, Vidhyaashram First Grade College. The Temple of Excellence, MYSURU. Before going into the subject, we have already discussed what all we are supposed to study in this particular subject in the introduction class. Okay, depends on the syllabus. Before going into the subject, let us see what is data structure. As name of the subject itself says, that we have two variables there. One is data and one is structure, right? So how to structure the data is nothing but data structure. What we are going to learn? We are going to learn how to structure the data. So definition for data structure. What is data structure? Data structure is a method of storing the data and organizing the data in the computer memory so that that can be used efficiently. Why we have to store or why we have to organize the data and where we have to store and where we have to organize the data. That is most important question what we have. Why we have to store? If you have lot of clothes putting together one on above other, so is it possible to fetch your favorite cloth out of it? No, right? If you have done, arranged the clothes properly, segregating in each sessions, it is easy to access. Right? Similarly, data also work. We have to store, we have abundant of data. So how to store that data, where to store that data, and how the organization of data should be there. That's we are going to learn here. Why we have to store the data? We got the answer, right? To fetch it very easily. And where we are organizing this data? We are organizing this data basically on the computer main memory. What is computer main memory? That is your RAM, right? Random access memory. We are organizing this data to the RAM. Why only to the RAM? When any program is executing, that program has to be fetched from any other storage location to the main memory. When the programs come to the main memory, then only it is possible to execute that particular program or that particular piece of code. So, it is very important to organize that particular data, that particular piece of code, here we refer it as data, into the main memory so that the operating system can execute that. So, that is what we are discussing here. Definition of data structure: storing and organizing a data into the computer main memory. Then, data structure mainly deals with what? The first most thing, it is deals with how data is organized in the main memory. How to organize the data into the main memory. Then, how efficiently data can be stored in the main memory. Okay. Then, how efficiently data can be retrieved and manipulated. If you have organized it properly, you can store it in proper sections, right? First, to store any clothes, you should fold that clothes properly. That is called as organizing. To keep it in separate section, that is called as storing. And retrieving, to fetch your favorite cloth for that particular occasion, is called as retrieved. We refer it as retrieving. So, organizing, storing and retrieving all can be done efficiently if we are using a data structures. Then, the possible way in which different data items are logically related. We can relate one data item to the other data item when we are storing it properly. As I told you, what is data? Data is what? Large fact that it has to be converted into the information so that machine can or user or developer can understand that. So here that is a definition. What is data? Data is a collection of raw fact. It is raw fact. There is no point, no understanding in the data. When it will become information, the data, the processed data becomes the information. It has some meaning to it. To provide that meaning, we are using the data structures. Next, different types of data structure we have. How many types of data structure? Mainly the data structure is categorized into two categories. One is primitive data structure and second one is non-primitive data structure. What is primitive data structure? The basic data structure what you have studied in C. Those all falls under primitive data structure like integer, floats, character, pointers. This all falls under primitive data structure. What is non-primitive data structure? The non-primitive data structures are the data structures that are derived from the primitive data structures. Using these four primitive data structure, we are going to define some more data structures so that we can manipulate the data easily. That is called as non-primitive data structure. You can see here further non-primitive data structure is divided into linear and non-linear data structure. Okay, what is linear data structure? Linear data structure, we are storing the data in the sequential manner. Okay, in non-linear data structure, data will be stored here and there, but it is connected to one and another. That is called as non-linear data structure. This is a rough idea about types of data structure. We'll see in detail one by one. Okay, what is primitive data structure? As I told you, primitive data structure are the very basic data structure that can be understandable by the compiler. That what we are seeing are data structure that can be manipulated directly by the instruction, which computer can understand and process on that. That is called as primitive data structure. As an example, we have integer, floating point, numbers, characters, and then the pointers. These are all some of the primitive data structures where the compiler understands that and will process on that particular data. Next, what comes with a non-primitive data structure. Non-primitive data structure, a structure that cannot be, here you can see, that cannot be manipulated directly by the machine instruction. Machine cannot directly understand. That is called as non-primitive data structure. They are like user-defined data structure. Using primitive data structure, we are defining some data structure. That's why it is called as user-defined data structures. Non-primitive data structure can be again divided into linear and non-linear data structure. Let's see what is linear data structure. What is linear data structure? Where the data to be stored in the sequential memory locations. Data structure where the elements are stored in the sequence one after the other or in the linear manner. So we call it as linear data structure. What are the example for linear data structure? You already studied C programming, so it won't be difficult for you to understand what is this. What is this? Array of 10 element. If I say array of 10 element, how the memory will be allocated for the array of 10 element? Continuously, like A of 0, A of 1, A of 2, like this continuously up to A of 9 it will be allocated continuously. If I say what is the address of this memory location, say it is 1000 is the address of this memory location, this will be 1001, 1002, so on up to 1009. Like this, how continuously we are storing the data or the elements within the data structure. That's why it is called as linear data structure. Example, as we took an example of array, array is one of the most used linear data structure. Then coming into the stack. What is stack? In stack also is a structure represented with one end is closed and another end is open. So stack is what? Whichever the elements come into the stack first, that will be retrieved out last. So if I say these are some of the elements that has been stored here, A, B, C and D. So when we are taking the element out, we cannot take from here, we have to insert from one end and we have to retrieve from the same end. So that type of data structure is called as stack data structure. Here both insertion and deletion both will be done at the same end. So we call it as first in, last out of type of data structure. So if we want to take A out, we have to take all D, C and B out first, then we have to take A first. That is, whichever inserted at first, that will be taking out at the last. That is a definition what we have for the stack here. It is a data structure where the elements are inserted and deleted from the same end, which is called as stack. Hope you understood what is the concept of stack. Concept of the stack in first in, last out, or we can say last in, first out. First in, last out, or last in, first out. Then another example what we have is queue. Queue is a type of data structure. There we have two ends. Okay, insertion from one end and deletion from another end. So we can write the queue data structure like this: insertion from one end and deletion from another end. Okay, so what we have is insertion end is called as rear end and deletion end is called as front end. So whichever the element inserted, first A, B, C, D and E, so on, that will be deleted first. So it is called as first in, first out concept. What is queue? First in, first out concept, where we have the data structure where the elements are inserted from one end and the deleted from another end. Insertion end is called as rear end and deletion end is called as front end. Next type of linear data structure is linked list. What do you mean by linked list? Here the data will be stored in the form of nodes, not in the, it is a linear structure. Also data will be stored in the form of nodes and node will be having two fields in this. What is a first field? Data is a first field and a link is a second field. So another node, what we have is data and link. This link of the first node will provide the address of second node. What link will provide? Link will provide the address of second node and data field provide the actual information which has to be stored. Okay, that is called as linked list. The data structure which has a collection of nodes, where every node will have data field and then the link field. Every node will be having two fields: data field, link field, data field, link field. And the data field contain the actual information, the actual data which is to be stored, and the link field is a pointer. It acts as a pointer to the next node. That is all about the different type of non-primitive linear data structure. Let's see non-primitive, non-linear data structure. Here we are going to discuss non-linear data structure. In linear, we are storing the data in the sequential manner, but in the non-linear, we are storing the data somewhere in the memory, but each and every node is connected to each other. So that is what it says. It states data structure where the elements are not present in the sequence, but they are in the random position, here and there, scattered in the random position. Here one element is connected to the n number of other elements. We have a connection between each elements. Such type of data structure is called as non-primitive and non-linear data structure. Example for that is tree and graph. What is tree and graph? These are an example for non-linear. How do we represent that graph? Graph is a collection of nodes connecting with the edges. So that is, see, we have node A, node B, node C and node D. It's a collection of node connecting with the edges. How we are providing the connection? Using the edge. Right, and this is what? Node. Okay, graph is a data structure which has a collection of nodes and edges. Each node is connected to the other node using the edge. Okay, we have different types of the graph like connected graph, unconnected graph, weighted graph, then directional graph, and undirectional graph. So there are different type of graphs we have. We can use any type of the graph, depends on the requirement what we have for the program procedure. So what we have given is a connected graph. In place of this, if I remove this particular thing, then it is unconnected graph. We don't have a connection from node C to any other node from A, B and D. So this is unconnected graph. If we say what is weighted graph, each graph will be having some value, 30, 20, each node will be having some value. So these values will be called as, when the node will be having the value, that is called as weighted graph. Directed graph means it can be directed towards one particular node. It can be single direction or it can be bidirectional. Both will be comes under directed graph. Undirected graph means, as we have given the first example, there is no direct. Either you can move from here to here or here to here, but in the directed graph you have to move from node A to node B only, from node B to node D only, like that. That is called as directed graph. This is all about a simple introduction on the graph. And then what we have is another example is tree. What is tree? Tree is a data structure where the elements are stored in the hierarchical manner. Hierarchical manner means, here also we can say it is a collection of nodes. This is what? Hierarchical manner. Okay, and one above the other. We have different terminologies in tree. So this particular node is called as parent node, and this is called as child node. Okay, and these two will be called as siblings. Siblings for whom? Sibling for either D, sibling for either C. So each will be, which are at the same level, is called as sibling. Which is at the above level, we have a parent, we have a ancestors also. Like if we are giving with the levels, level 1, level 2. There are different levels. So we are putting the data in the form of hierarchy. That is what we call it as tree. So this is all about a non-primitive data structure, linear as well as a non-linear data structure. Next, what we have is operation on the data structure. We got to know what is data structure and what all different types of data structure and example for each type of data structure. Now let us see what is the operations that we can perform on the data structures. So these are all some of the operation that we can perform on the data structure. First one is traversing. Traversing means moving from one place to the other place. As we are traveling daily from home to the college, from college to somewhere, like that. That is traversing, traveling from one place to the other place. Here with respect to data structure, we can say traveling from one node to the other node. That is called as travel. We can traverse from one node to the other node using the intermediate nodes. That is called as traversing. Traversing the data structure means visiting each element of the data structure in order to perform some specific operation like searching. Why we have to traverse? To search which element is present in where. To search that, we are doing the traversing. Next, What we have? Insertion. Insertion means inserting some value dynamically, randomly. That is called as insertion. We can perform insertion operation on any of the data type. Insertion can be defined as a process of adding the elements into the data structure. Before insertion, we have to do what? Create data structure. That is also one of the operation. We can create the data structure. Once we have created, if we want to add some element into the data structure, then we are moving into the insertion operation. Then deletion operation, taking out of the element from the given data structure or from created data structure. That is called as deleting. The process of removing the element from the data structure is called as removing or deleting operation. And searching. Searching means, as we know, which data is present where, that is called as searching. So the process of finding the location of the element within the data structure. If I want to locate A of 3 in the given array A of 5, so how do I do? I do 1, 2, 3, 4, 5. So this is my third position. I can search using the data structure. Directly if I give A of 3, it will give the value as 10, right? It will give the value as 10. So that is what? Searching. We can search for particular element in the data structure. Then sorting. Sorting means either you can arrange the data such that it should be in ascending order or it should be in the descending order. Okay, why we have to sort? To make search very easy, we have to sort. For example, if you can say, if I store the value here like 1, 2, 3, 4, right? How many elements we have stored? We have stored 4 elements, 1, 2, 3, 4, which is in ascending order, right? As I say, I can compare 2 elements here. 1 is less than 2. So it is positioned here. 3 is greater than 2. So it is positioned next to 2. It is easy to search particular element when we have a sorted array or the elements are in sorted manner. So we have to go for sorting operation. The process of arranging the elements of the data structure in the specific order is called as sorting, either in the ascending order or in the descending order. So that is called as sorting. Next, what we have is memory allocation. As we have seen, we have to allocate a memory for each data structure in the main memory. How we are going to do that allocation? How the memory will be represented? Computer memory we represent like this. So this is a different memory blocks we have. So if I have A of 5, so if I have A of 5, where exactly this A of 5 is located in the main memory. So if I declare this, the 5 block of memory has to be allocated for this particular array. How this allocation is done? So we have 2 main types of memory allocation. One is static allocation and second one is dynamic allocation. Static allocation, as all of you can know, what is static allocation? Allocation once done, it is static. We cannot change the value of that allocation. Okay, then dynamic, we can change dynamically as when the program is executing. So there are 2 different type of memory allocation. One is static and second one is dynamic. Let's see what is static allocation. In the static allocation, what we are doing, allocating the memory during the compilation time. When we are allocating the memory during the compilation time, that is called as static memory allocation. Here, once size of the memory is allocated, that is fixed. Once we have given as A of 5, it will allocate only 5 blocks of memory. You cannot extend that or you cannot delete that. So that is a thing what we have in the static allocation. It cannot be altered even during the execution time. Consider the following declaration, that is int A of 10. 10 means 10 block of memory will be allocated. for the variable or for the array A. So that is what is the disadvantage we have in the static memory allocation. We majorly have two disadvantages. One is we cannot change, right? So if we cannot change, we cannot add extra element into the data structure. Yes, and we cannot remove the memory space from the data structure. That is a disadvantage what we have. The memory allocation during the compilation time is memory allocated is fixed. It cannot be altered. Leads to underutilization of memory. If I declare A of 10 and I am giving only 0, 1, 2, 3, 4 and 5 as an element of array. How many elements I am giving? I am giving only 6 elements. Right. So, in this particular array A of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 0, 1, 2, 3, 4, 5. Okay. So, we have allocated 10 blocks of space and we are giving only the 6 elements. So, this will be used and remaining this element will be waste. Right. So, what happens to that memory? We cannot use it for some different purpose that simply will occupy the memory in the main memory. So, that we cannot do. That is what we can underutilization of more memory. We are not utilizing complete memory which is allocated for that particular array. This is one disadvantage. And the second disadvantage, I have given it as 4, 5, 6 elements and 6, 7, 8, 9, 10, 11. I have allocated 11 elements into the array. So here what happens? Here again we can say 6, 7, 8, 9. What about these two elements? Where do I store these two elements? So it comes with the overflow if the memory is less. So understood the difference between underutilization and overflow of the memory. So we are losing the data here. Data of 10 and 11 will be lost that cannot be stored in this particular array. So that is one of the major disadvantage what we have in the static allocation. The static nature imposes certain limitation to find their appropriations only when the data is fixed and known before processing. When we have to use a static? When data is fixed and before using it, we should know how much of memory it will take. That time only we can use a static allocation. Then coming into the dynamic allocation, as we have seen the disadvantage of static allocation. So, to overcome from that disadvantage, we are using the dynamic allocation. It's a process of allocating memory during the run time, where static is during the compilation time, during the runtime or execution time. This technique uses a predefined function to allocate and release the memory of the data. There are predefined functions like malloc, calloc and realloc. Using those functions, we can allocate the memory dynamically. So during the execution time, example, when we are using the trees and linked list, we are going for the dynamic allocation of the memory. So coming into the difference, what is the difference between static allocation and dynamic allocation? The static allocation, memory is allocated during the compilation time. In dynamic, memory is allocated during the runtime. The first and major difference what we have. Here the size is fixed. In the static allocation, memory size is fixed. In the dynamic allocation, it is not required to be shift. We can allocate and we can deallocate at any point in time. Then uses only when data size is fixed. When we use a static allocation, when we know only this much of data is required, that time only we are using the static allocation. When it comes to the dynamic allocation, when data is unpredictable, at that time we are using the dynamic memory allocation. A major difference between that static and dynamic is static execution is faster compared to dynamic, because we have already told the compiler this much of memory I need and that much of memory is already allocated. This is just an example. When we go to the hotels, if you reserve it previously, the table is reserved for you. You go sit, order and do it. If you are not reserved, you have to go. If it is filled, you have to wait for some time. Then whichever the table is free, that will be allocated for you. Then you start ordering. So it is faster. As we have declared how many blocks of memory we need, that is faster. Here we don't know how much memory. We have to wait until unless memory allocation is done. After memory allocation, we can do the execution. Okay, next point is that memory is allocated either in the stack area or in the local variable area. Here memory is allocated in heap area. What is heap area? I will discuss in the next slide, heap area. And the example for static is array. Example for dynamic is trees and linked list. This is a major difference what we can categorize between the dynamic allocation as well as in the static allocation. Next, memory map of C programming. How the memory is mapped in the C programming. There are 4 different segments of memory mapping in the C program. In the first segment, what we have is a text. Text is nothing but whatever the instructions you are giving as a program statements. That is nothing but text segment. We have a separate dedicated section in the memory to hold the text segment. Initialization data segment. Whatever the variables we initialize, like int A, int B or int result, like that, whatever the variable we declare previously, those is called as initialization. We have a separate segment to store the initialization of data, and uninitialized data segment. For both we have separate session and heap and stack. So let's see the memory representation, how we are doing it. So here address move from bottom to top. It will move bottom up approach. So here we have a lowest address, say it is 0000. This is my lowest address. Here we have 10000000 some. It depends on the processor what you are using. Like, so the lowest address will be given for the instruction. Text is nothing but the instructions here. Okay, whichever the instructions will be given, like int main, void main, those all instruction will be stored in the text area of the memory, which is dedicated for instructions. This is uninitialization, and initialization will be used for global variable and local variable. Whenever we are declaring or initializing the value for global variable and the local variable, that will be put in this location of the memory. Here we have a heap. This complete section is called as heap. Now you can understand how large heap is. Heap is a large block of memory where the dynamic memory allocation can takes place. What about the stack? Here the initialization of variable, whatever the static allocation, like if you are giving x is equal to 5, that will be given here. A of 10, that will be given here. So this all static allocation will be allocated to the stack location in the memory, and the dynamic allocations will be taken care by the heap location in the memory. So remaining common command line arguments and environment variables will be there at the topmost higher address level. Okay, this is how the memory is represented for the C programming. Next, what we have is memory allocation. How many types of allocations we can do in dynamic memory? Different functions are there. As we have discussed, dynamic memory can be allocated using the pre-built functions. What are those functions? So functions are malloc, calloc and reloc. To allocate and to deallocate, we have free. How many functions we have to allocate? 3 functions we have for the memory allocation and 1 function for deallocation of the memory. So whenever we are doing any of these functions, we have to make use of pointers. Whenever we are saying that the only way to access this dynamic allocation by through pointers. Okay, only with the pointers we can allocate or we can deallocate the memory. So let us see one by one what is malloc. Malloc is a complete formation, is memory allocation. What is malloc? Malloc is memory allocation. So what would be the syntax for memory allocation? All the functions whatever we said, malloc, calloc, reloc and free, all function will be stored in the standard library function, and so we have to include with standard library function .h as a header file to use those particular pre-built function. So the function allows the program to allocate the memory explicitly and when required and extract the amount needed during the execution. Exact amount, how much memory we need for that particular execution, that much will be allocated using the memory allocation function. This function allocates the work of memory and the size of the blocks in the numbers of byte specified in the parameter. How many size of memory blocks we want, that has to be specified as a parameter for that particular function. Here you can see, as I told you, each allocation function make use of pointer. So pointer is equal to data type. Which data type or which type of data you want to store or you want to keep it in the memory. So that data type, and we are calling the malloc function. This size represent how much we want, how much memory we want, that will be represented. So that's what we are discussed here. Pointer represent to point which memory location, data types gives which type of data you are storing, malloc is a function, and size is a size how much you want for that particular execution. That is what has passed as parameters. Size is passed as parameters. For example, here we can say this is my memory allocation. So here somewhere I have stored the value 100 and this memory location will be 2000. If the memory location will be 2000, the pointer value will be 2000 is equal to, what is a data type? Integer is a data type, malloc is a function, and what is a size? Size is 4 bytes. So that is how we are going to represent. So if memory is not allocated, what happens? We have the function name, ptr is equal to data type, malloc, and the size of the memory block what's supposed to be allocated. If the pointer is equal to null, if this pointer is not pointing to any location of the memory, it's giving the null value. If it is giving the null value, then what? We are saying that there is a insufficient memory. We don't have memory to allocate. So that is insufficient memory and we are exiting from that particular piece of code. So that is what about allocation, and what if the allocation is not done. This is responsible for the programmer to check whether the sufficient memory is allocated or not. Whose responsibility to check the memory is full or not, insufficient memory is there? It is exactly the programmer responsibility to check and allocate. Next what we have is syntax for malloc function. C syntax. Int is what? The pointer type. Pointer is of which data type? Pointer is of integer data type. And we are allocating the memory for what data type? We are allocating the memory for integer type of data type. And what does this 5 represents? I need 5 blocks of memory. I need 5 blocks of memory of the size int. Int means you can have the integer for 2 bytes as well as for 4 bytes. One integer value will hold 2 bytes of memory, or one integer value can hold 4 bytes of memory. Right. So one integer can hold, it depends on the processor or the motherboard what you are using. So if nowadays all will be using this 4 bytes only, okay, as the processor is improved a lot. Okay, this 4 bytes of memory, it's a size of integer. What is the size of integer in my processor? The size of integer is 4. So how much memory block I want? I want 5 memory block of the size 4 integer value. So what would be the memory block assigned? 5 into 4, that is 20 bytes of memory will be allocated for any C programming. A larger 20 byte memory block is dynamically allocated for this particular pointer. Okay, getting the thing about memory allocation. Then what comes with the Kellogg function? Next function is what? Kellogg, continuous memory allocation. Kellogg stands for what? Continuous memory allocation. So there we are having only one size as a parameter. Here we have two parameters. How many parameters we have? Two parameters. When to use malloc and when to use Kellogg? For simple memory allocation, for declaring one variable allocation, we are using the malloc. If you want to declare the array allocation, that is what we done with the last slide, 5 into number of size of the data type. When we need more continuous memory allocation, for example, if this is my memory block, I need this continuous memory block, this complete memory block. At that time we are using a Kellogg type of function, Kellogg function to allocate larger memory. Okay, let's see. This function is to allocate the multiple blocks of memory. So how many blocks we are allocating? 1, 2 and 3. Multiple blocks of memory we are allocating. Kellogg stands for continuous allocation of multiple blocks. Continuous allocation of multiple blocks. When we are used allocating the memory for array, especially most of the time we use for array. The number of memory blocks are determined by the first parameter. How many blocks? 1, 2, 3. How many blocks? That is determined by the first parameter, that is n. Okay, first parameter, that is n. And the size of each block is equal to the number of bytes specified in the parameter size. What size will give? Number of byte. Size will give what? Number of byte. Let's have a syntax for Kellogg function. As I told you, this must be same because all the inbuilt function for the dynamic allocation will be stored in the standard library header file. So take standard library header file. What is P? P is a pointer which is pointing to that particular memory location. Then what is data type? What type of data you are storing into the memory block? Kellogg, and two parameters. First parameter n represent what? How many blocks of memory you want. Second parameter size will represent how many bytes you want. So on the successful allocation, the function will return the address of first byte of allocation. Which is the first byte of allocation? This is my how the memory is stored. I have three different blocks, 1, 2, 3. What is the first block address? 2000. So pointer value is equal to 2000. From 2000 we have continuous allocation till 2004, 2008, like that. We have continuous allocation of the memory. On failure, the function return nulls. On failure, what? PTR value is equal to null and function returns null value, saying that it's a insufficient memory. The syntax of Kellogg function in C. How we are representing Kellogg using the Kellogg function in C programming. What is int? Data type. That pointers belongs to int, where the data type to be stored. Kellogg size is 5. How many blocks of memory I want? I want 5 blocks of memory How much of the size? I need 4 bytes each size. So we are allocated with 20 bytes of memory. If this size will be 10 and size of is how much bytes a character will hold? Character hold 1 size. So in place of this, Kellogg 10 comma size of char. If I give, how much bytes of the memory will be allocated? Kellogg 10 will be as it is. Size of the character is 1, that is 10 into 1. So 10 bytes of memory will be allocated. But when it's for the integer byte is 4. So 5 comma 4, it will be allocated with 4 blocks each, 4 blocks each, 4 blocks each, like 4 blocks each. So 5 blocks of 1, 2, 3, 4, 5. 5 blocks of memory of 4 bytes each will be allocated. Next what we have is malloc on Kellogg on failure. As I told you, it's if the pointer value is equal to 0, it says insufficient memory and it will return back to the function. What is the difference between malloc and Kellogg? Malloc function is created 1 block of memory of fixed size. As the function name itself, only 1 block will be created. In the Kellogg, continuous block of the memory will be created for the single variable. Very important, memory for the single variable. It takes only 1 argument. It takes 2 argument, n and size. Here only the size. It is faster than Kellogg. Because the number of memory blocks is less, it is faster, it is slower compared to the malloc. High time efficiency, as it is faster, the time efficiency is more. As it is slower, it has a low time efficiency. It used to indicate the memory allocation. It used to indicate the continuous memory allocation. The syntax what we have is wide malloc size of, wide malloc n into size of. Then it does not initialize the memory blocks to 0. Here it will take the garbage value. Here all will be initialized to 0. The memory block which is initial, we don't have a value, it will be initialized to 0 and here the garbage value will be taken. It does not add any extra memory overhead and it adds some extra memory overhead because it is a continuous allocation. This is a major difference what we have between malloc and then the Kellogg. Then what we have is realloc. To do a realloc function, first and foremost important point is that there should be one allocation function. Reallocation means what? We are allocating the size, we are extending the size which is already allocated. So the main condition to use the reallocation function, either malloc and Kellogg function should be called before reallocation function. So this is a syntax what we have here. Data type, reallocation function, pointer. What is a pointer? Pointer that is created using the malloc function or then the Kellogg function which is already created, and how much extra size we want, that size we are supposed to represent. Then syntax for reallocate function, as we have given here. First they are using the Kellogg. As I told you, for reallocation either Kellogg function or malloc function should be called. By using the Kellogg function, we are defining 5 as a memory blocks and the 4. So how many bytes? 20 bytes of memory is allocated here, right? 20 bytes of memory is allocated. This memory is not sufficient. We feel when executing the program, this memory is not sufficient. I want to add some more memory blocks. So at that time, I can call the function realloc. So we have 20 bytes of memory. So when we are doing the reallocation, for this memory is not sufficient and we want to add some more memory blocks, at that time we are going for the reallocation function. For reallocation, you are declaring one variable or pointer. This pointer, which is a parameter for reallocation function, should be same as that of the pointer that is declared in the memory allocation function. Okay, then size is equal to 10. What is the size? 10, here we have declared it as 5, here we have declared it as 10, and size of integer is 4. So totally 4 into 10, 40 blocks of memory will be allocated. How many bytes of memory will be allocated? 40 bytes of memory will be allocated. This 40 byte is not excluding 20 byte, that is including 20 bytes. We are just allocating extra 5 blocks of memory using the reallocation function. It will take the size this plus new allocation. It will take the size of old allocation plus new allocation. So the 40 byte of memory will be allocated as a reallocation function. Next, what we have come through with the different functions for memory allocation. So one memory is allocated, program executed, it's terminated. Then what happens to the memory which is allocated dynamically? We have to free that memory. So as a same example, I can quote you again. When you go to the restaurant, you will sit in the table, you will have your dinner or the lunch. Once you are done, you are supposed to leave that space so that other can come sit and have their dinner, right? That is called as deallocation. How we are deallocating the memory in the C programming? By using one function called free. Free is a function that is used to deallocate the memory. So this function is used to deallocate the memory or free the memory allocated block which allocated by the function malloc, calloc and relloc. We can deallocate only such memory blocks which has been allocated by using the functions malloc, calloc and realloc. The responsibility of the programmer to deallocate the memory. Whose responsibility is that? It is the programmer responsibility. Once it is done, you have to deallocate the function. Let's see the syntax of free. As I told you, std standard library header file should be included. Free pointer. What we are freeing? Pointer. Because we are allocating the memory using pointer, so we have to free the pointer. Pointer as initiated to null. If the pointer is initiated to null, whatever the memory value will be there, like 2000 something memory value pointer will be pointing, that will be initiated to null and it will be freed. It will be free to access or loaded by some other program. So this is a syntax for free or deallocating the memory. So syntax in C program, once to use the free function, there should be the allocation function. So allocation function we have, then 20 bytes of memory is allocated using the allocation function. Operations on pointer, then what we are calling? We are calling free pointer. Once we are doing free pointer, this pointer is initialized to null. So at this particular point, memory will be released and that 2000, what is the content is there in the 2000 will be sent to bin, that will be deleted. So this is the operation what we have for the free in C. That's all for this session. Thank you.